Johann Carl Friedrich Gauss was born in 1777 and died in 1885. He was a German mathematician who contributed to many fields of math, such as number theory, algebra, statistics, and many more. Gauss was the son of a poor working class parents, but he was considered a child prodigy by his teachers, where by the age of 8 he figured how to add up all of the numbers of 1 to 100. One of the most important contributes of Gauss was the Gaussian addition.
Gauss created the Gaussian addition to determine the numbers of 1 to 100. Firstly, he wrote the first three numbers, which were 1, 2, and 3, then 98, 99, and 100, and then he wrote it by the other side. He started with 100, then 99, 98, and then 3, 2, 1. When he added them up, he saw that both sums give 101. So he established the relation that 2s equals 101 times 100. So what he did was to make s as a subject. So he passed the 2 to divide, and he saw that 101 times 100 over 2, it equals to 550, which is the sum of 1 to 100 to 100.
What is a sequence? A sequence is an ordered list of numbers. The numbers in its ordered list are called terms. For example, 1, 2, 3. What is a series? Is the value you get after you add up all the numbers in a sequence. This value is called sum. There are arithmetic sequences and arithmetic series, but arithmetic refers when you go from one term to the next by always adding or subtracting the same value. For example, an arithmetic sequence of 2, 5, 8, 11. It also exists geometric sequences and geometric series, but the term geometric refers when you go from one term to the next by always multiplying or dividing the same value. Who was Cantor? George Ferdinand Ludwig Philipp Cantor was born in 1845 and died in 1980. He was a German mathematician who established the importance of one-to-one correspondence between the members of two sets. He defined infinite and well-ordered sets, and proved that the real numbers are more numerous than the natural numbers. Cantor proved the existence of an infinity of infinities.
In interest, there exist two types of interest. The simple interest, that is money you can earn by initially investing some money, which is the principal, and the compound interest, which is the addition of interest to the principal sum of a loan or deposit. Here there are two formulas, which is for the simple interest, this is the formula, this is the principal, the rate of increment and the time,
And the compound interest.
With this in mind, we can define what is E. E is a mathematical constant that is based of a natural logarithm.
It approached the number 2.71828 and is the limit of
1 plus 1 over n to the power of n as n approaches infinity. This studies compound interest. Talking about infinite geometric series, you can take the sum of an infinite geometric series, but only that the common ratio has an absolute value between -1 and 1. You have to have this expression: absolute value of r is less than 1. And why there is not an infinite arithmetic series? Because you don't sum infinite arithmetic series because it diverges. Diverges means that it never ends and has no sum in the usual sense. So the answer has no sense at all. But there exists some types of infinity, which are the countable infinity that we can see an example 1 plus 1 plus 1 plus 1. The Aleph null is the number of counting numbers, for example 1, 2, and 3. Cardinal numbers, ordinal numbers, this is 1 plus omega. It exists the hyperreals and the surreals, and there are some others.
I'm going to give some exercises of sequences and series and infinity.
The first exercise I'm going to show is the chess problem. In order to understand the problem, we need to have a context. There was a legend which talks about a king was very kind toward his kingdom, but he was in a war against other kingdom. In one battle, his son died, and he was very depressive about the results. They win, but he lost his son. And on one of those days, a young boy came to talk to him and show him a game that is the chess, and make the king understand that sometimes you need to sacrifice some soldiers to win the battle. The king was amazed with the game. I told him that the boy can ask for whatever he wants. The young boy asked for a reward that for the first box of grain they give in. For the first box, they give in a grain of wheat. For the second box, 2 grains. For the third, 4 grains, and so on to finish until the 64 box. In here, we can see a geometric sequence problem that the king didn't take into account because he thought that those values were not important. But if you make the calculus, you can see a geometric sequence. It has a common ratio of 2, and we can use the sum of the terms, which are 64, and we can get as a result 1.845 times 10 to the 19, which is a very big number. So in contrast, the king couldn't accomplish what he promised, but he converted the young boy into one of his advisors.
Hilbert was a great mathematician of the 20th century. He stated the Hotel problem, which describes infinity. He says that there was a hotel with infinite rooms. Each room was full occupied, but when a person arrives, the manager gives him a room, and the person who was in the first room goes to the second to the third to the fourth, and so on until infinity. But then, when another guest arrives, that person moves to the first room, the person who was on the second moved to the fourth, the person who was on the third moved to the sixth, the person who was on the fourth moved to the eighth, and so on. Each time it moves by two rooms. So what he wanted to show was that all the rooms were full, but when a person arrives, the manager managed to give him a room and move the other guests to the next ones.